So we had gone through, yesterday, we had gone through our notes and we had taken a look at what the factors and the levels are. Let's kind of review that real quick. I'm actually on page 10. I want to just remind you. A factor is that general type of treatment, like a medicine or the type of exercise, okay? And so factor is that more broad idea. It's actually your explanatory variable. What is explaining the cause? Okay, so let's actually put that in there real quick. Back there on page 10, let's go ahead and put that in there. A factor is also the explanatory variable. It's what is explaining the cause. Okay, so it's what's explaining the cause. Or explains the results. It is the cause. It is the cause. It explains the results. Okay, and then the levels are just the different values of them. You know, like 10 grams, 5 grams, 0 grams. Okay, the levels are just the little subcategories underneath. All right, so we'll remember that. And then we had SRAT me catted. We learned how to do that yesterday, adding that T. So let's go ahead and go on to this page 11. All right, so here we go. Page 11 has got it's got a problem. So we end up having a scenario at the top, and then we're asked some questions about it. And first thing we want to know is the situation an observational study or an experiment, okay? So as I read through this problem number 1, I want you to decide if it's an observational study or if it's an experiment. Real quickly, what's the difference between those two? Experiment what? Has a treatment. Perfect. Excellent. Experiment has a treatment. You're assigning subjects to a treatment. Observational study, you're just what? Watching them. Very good. Okay, here we go. Over a 4-month period among 30 people with bipolar disorder, patients who were given a high dose, which was 10 grams a day, of omega-3 fats from fish oil, improved more than those given a placebo. All right, so would that be an observational study or an experiment? It is. How do you know it's an experiment? Because they're giving this patients something. What are they giving the patients? Good, that fish oil or a placebo. And what would the placebo be? Nothing. Okay, very good. So now look at this next section. It's the rest of the page is divided into 2 parts. These first ones say, if it is an observational study, then answer these questions. Well, it's not, so we don't even do those top 4 problems. That's nice, right? Okay, so we're going to answer these bottom ones. So here we go. All right. Who are the subjects studied and how were they selected? So who are the subjects in this experiment? Perfect. The 30 patients with bipolar disorder. Perfect. Good job. Oops. So up here, 30 patients with bipolar disorder. Are they randomly selected from the population, or would they have to be volunteers? Yeah, because we're going to be having them take a medicine, and so I'm pretty sure we're going to have them be volunteers. So they would be volunteers. Okay, remember, what's the benefit of randomly select? Randomly select. If you randomly select, then you're what? Then your samples like the population, and so then you can do what? You can generalize to the whole population, but volunteers might be more desperate. Volunteers might be worse off. Volunteers might be more motivated to do really well, and so they think they're getting better faster. Volunteers are not like everybody, so we're going to end up being limited on who we can generalize to, okay? We can only generalize to volunteers. All right, well, let's keep going. The factors in this experiment, and then the levels. So what's the factor here?
10 grams.
Okay, so those are the levels. The 10 grams is a level, and then 0 grams is a level. But what is the more broad thing? Factor is a?
Placebo pill and regular pill.
Okay, the placebo and the regular, that's the 2 levels. Like, what is the broad general topic? Look up here. Yep. Look up here. Each a factor is a general type of treatment, like a medicine type or an exercise regimen. What do we have? What is our factor here? Good. Very good. So we have one factor. It is medicine type. And then we have 2 levels. And those 2 levels were 10 grams and the placebo, which is 0 grams. Okay. You can put placebo. You can put placebo because we know that placebo would be 0 grams. All right. So how many treatment groups do we end up having then?
2.
Good. We will end up randomly assigning our patients to one of 2 treatment groups. Excellent. Now, what is the response that is variable that is being measured? That means what are they seeing as the result? What's the response being measured?
Improvement.
Perfect. Improvement of what? Perfect. Improvement of bipolar symptoms, probably. Improvement of bipolar symptoms. So let's see. We're going to delete or not do problem E because that's the kind of design. We're going to learn that as we go through this unit. Now, how about this blinding? Is it blinded or double blinded? Do you remember the difference between those 2?
Yeah. Double blinded is both the doctor and the patient.
Perfect. And then if it's single blinded, then who is blinded? Just the patient. Okay. So what do we got going on here? Do we know if it's blinded or double blinded?
No, but we can just guess that it's blinded.
We know it is at least single because what?
There's a placebo.
There's a placebo. And what is the purpose of the placebo?
For not make it seem like, or to make it seem like you're taking a medicine and you're not.
Very good. So what would be the purpose? So we know it's at least single blind, and the reason is because that we know there is a placebo. We have been told that. So we know the patient does not know if he or she is getting the real medicine or a fake medicine. Why might that be important in this particular experiment? What's being measured? Bipolar disorder symptoms. Are those somewhat psychological? Yes, that's your mood. What's going on with your, how you feel. So that is somewhat psychological. So they want people to all think they're getting a medicine so that levels the playing field. And then we can see whatever is above and beyond that is the medicine working itself. Okay, very good. These last 2 are a little tricky, so let's see if we can't learn about these. What information would you be obtaining about the subjects? So we know we're going to measure each. Think about our Serapme capped. We're measuring each patient's bipolar disorder improvement. Now, would we compare an average or would we compare a proportion? How do you think you would measure their improvement? And this kind of you have to make up on your own. Would you say yes or no, they improved? Or do you think you probably want to know it like on a scale of 1 to 10? What would be best in this experiment? You think yes or no? Okay. And we could see, that's fine. We could vote on it. We could see who would rather just say yes or no, you improved, or on a scale of 1 to 10, how much you improved. Okay, raise your hand. That's your 2 choices. Raise your hand if you want to do proportion. Yes or no, you improved. Okay, a couple people there. Raise your hand if you would rather in this experiment place a number value on how much they improved. Why do you like that one better? We seem to have more choosing now. Okay, good. Do you think that's a little more descriptive? We can have more degrees of how much better they got. Okay, very good. I like that. You can really do either one, but since we as a class like average, we like it on a scale, then let's do that. So we're going to be figuring out the average on a scale of 1 to 10 improvement in symptoms. Okay, very good. All right. Now, to what population do you have the right to generalize your result? And can you claim cause and effect? So let's first indicate yes or no you can do cause and effect. Do we have a right to do cause and effect on this? Yes, we do. Why? Why do we have a right to claim cause and effect on this problem, this experiment? Because why? Ben, what'd you say? I think you're in the right direction.
Because they take the medicine, if their symptoms improve, or if the placebo.
Okay, what do you think, Carrington? Yeah, it's a controlled experiment. Remember with our little double bubble map that where we compared and contrasted observational study and experiment? Experiment can claim cause and effect. If you make an experiment, you can claim cause and effect. Observational study, no. Okay, so here we go. Yes to cause and effect because it is an experiment. Okay, come on now. You guys know the qualities of observational studies versus experiment. Okay, and then who can we generalize our results to? Can we generalize it to the general public of all bipolar patients? No, we cannot. We can only generalize to these volunteers only. They may be more desperate, more motivated, more something. Generalize to the volunteers only. Very good.
Generalize to the population?
Okay, so the reason we cannot to the population is because these volunteers, they could be in worse shape than the general population. They could be more desperate to get help than the general population. They could be more motivated to have improvement than the general population. So they are not necessarily like all bipolar patients.
What situation could you generalize?
Okay, you can generalize to all the population if anybody? If your sample's like the population, you can generalize. And your sample's like the population if you do what? Close, yes. Randomly select. The song is randomly select, no effect. You know you randomly select, no effect. You know you randomly select, no effect. When your sample's like the population, you can generalize. Okay? So that's when you can generalize to everybody.
That's really good, Ms. McCollum.
Okay, thanks.
You're welcome.
Maybe you didn't get that song. You were absent that day when we did those
No,
songs.
I was.
Oh, you're here. Okay. Very good job, guys. Now we're gonna, I'm gonna let you strap me cat that thing. How? So here we go. In this space up here, do you think that you can go straight to the strap me cat? I mean, I don't know. Do you want to do you like to do the diagram?
Yeah.
I tell you what, we're gonna see. This is an experiment on my part. I'm gonna see if you can be successful in your strap me capped and include everything without having to have a diagram, then you can just go straight to a strap me capped. If you want a diagram, do the diagram. But otherwise, I want you to take some time, make yourself your strap me capped right up here in this area that you got in your page up here for this problem. Okay, do that now. So I got my strap me cap written out. Let's go ahead and check that. So here we go. So start with your 30 bipolar patients. Okay, so that's what I got there. So start with your 30 bipolar patients. Randomly assign them with a big bag. So by putting them in a big bag, shake well, pull out half of the patients for each treatment. Or you could say 15 patients for each treatment because that's half. Okay, good. And then you state your treatments very well. So that your treatments are the 10 grams of fish oil or a placebo. Okay, and then ME is measure each patient's response to them. So remember I'm going to BS, I'm going to be specific, and I'm not just going to say measure each patient's response. That's not BSing. Measure each patient's bipolar symptom improvement. That is critical. If you leave off this little piece right here and you just said really generically, measure each patient's response, you have not basically defined what you are measuring. So that's why on AP exam, that is a critical component. And so it's important for you guys to say it in your experiment. Okay, Then we compare the average or the proportion. So you won't have both. You won't say, you'll use either the A or the P. So in this case, we're going to compare the average improvement of the two treatments to see. So compare the average improvement of the two treatments to see which treatment improves bipolar symptoms the most. And that's your strap me capped. Okay? So there you go. So, and again, I think I'm going to let you just go straight to this now that we aren't doing the diagram. All right, let's go on to the next problem, number 2. Here we go. So we're going to read this one and decide first and foremost if it's an observational study or an experiment. So here we go. An examination of medical records of more than 360,000 Swedish men showed that those who were overweight or who had high blood pressure had a higher risk of kidney cancer. And so that one was from a 2000 journal entry of the New England Journal of Medicine. So would that be considered an observational study or an experiment? Are we randomly assigning people to a treatment?
Observation.
We are observing what happened to them. So it's an observational study. So what that means is we don't have to strap me cat, and we don't even do all of this stuff down here. So we like observational studies. All right, here we go. So now, can you envision what's happening here? They just went to medical records and they pulled 360,000 files. And then they looked in the files and they separated them into those who had overweight or those who had high blood pressure, and then those who had nothing. So they've got a big chunk of files here. These are the ones that were overweight or had high blood pressure. So they got a big box of all of these files, overweight or high blood pressure men. And then they got ones over here, and these people were healthy, or they didn't have those two. They didn't have those two things going on. They were not overweight. And then you know what they figure out in here? They want to see what the risk of kidney cancer is. So when they looked at all of these files in this first box, what were they looking for? They looked at all those files. What did they look for then? How do you figure out what the risk of kidney cancer is? How do you figure out that rate of kidney cancer of those files? If there are 100 files in that box, how do I know the rate of kidney cancer? Okay, do I need to know and count how many in that box got kidney cancer?
Yes.
Yes, so I'm going to count. So think about what they're going to have to do. I'm going to count the number of these ones that got kidney cancer out of all of the overweight or high blood pressure files. So they're going to look in that box and make a fraction. How many of them got kidney cancer out of total over all the overweight and high blood pressure files? Okay, does that make sense? So then how are we going to get this rate over here of the healthy people? Same thing. I'm going to count the number of kidney cancer people out of the total healthy people, out of the total healthy files. So then I'll have these two percentages, and I can then compare these two percentages. And according to this, they said that the ones that were overweight or had high blood pressure had a higher risk of kidney cancer. So if I was to put an inequality in between these two, how would it look? This rate of the overweight people and high blood pressure people was higher proportion than the healthy people. Okay, so that's how they would do that observational study. They just set the files in piles and then do their counting. All right, was this retrospective or prospective? Thinking of these words, retro and pro, what would that be? Retro is what? In the past. So is this in the past? Yes, because they were medical records that they pulled their files. So this would have to be retrospective, looking back. So it was retrospective. Okay. Who are the subjects studied and how were they selected? Who?
360,000 Swedish men.
Yeah, 360,000 Swedish men. They didn't just pick overweight and high blood pressure people. They picked all the Swedish men. All the Swedish men's files. Well, 360,000 Swedish men's files. And then they sorted them. Those who were overweight and high blood pressure or those who were healthy. Okay. What are we interested in obtaining about these subjects? What do we want to know? An average or a proportion? Hello, what am I making right here? What is this fraction considered? And that is, this fraction is considered a?
Proportion.
Thank you. So we are figuring out the proportion of overweight, slash high blood pressure men who got kidney cancer. And by the way, we're also figuring out that proportion of the healthy ones who got kidney cancer. Okay, the proportion of the overweight and high blood pressure men who got kidney cancer. We're also doing it for the healthy. Okay, what nature and scope of conclusion can we reach with this? Can we claim cause and effect? Can we say overweight or high blood pressure causes kidney cancer? No, you cannot, because there could be other things going on. If people are overweight or have kidney cancer, if people are overweight or have high blood pressure, what else could be happening with them that could contribute to kidney cancer?
Chemicals in the food.
Chemicals in the food. Maybe they eat worse food. Maybe are they eating more preservatives than the healthy people? We don't know what is actually the cause of the kidney cancer. So we can know cause and effect. No cause and effect. Now, we're going to claim that these were randomly selected files. There's no need to really force a treatment on them. So we're going to pretend like these were randomly selected files. If they were randomly selected, then who can we generalize to? Yeah, and the population is probably not all men, but probably what?
Some men.
Swedish men. Because you know how different, I don't know if you know this, but different countries, have different, types of foods and cultures and activities and stuff that they do. So we want to kind of keep it within that group. Okay? All Swedish men. Very good. So now, your final goal of the day is to read number 3, and if it is an experiment, which I'm not saying if it is or not, then I want you to Srat me capped it. But there is one thing. There's a little bit of it's ambiguous here in this problem. So I'm gonna guide you through it so you can clearly see, because it's not very clear on what the different diets are that they have here. So let's read this. To research the effects of dietary patterns on blood pressure in 459 subjects. These subjects were randomly assigned to 3 groups and had their meals prepared by dietitians. So there was 3 different groups, okay? And here's what they are. It's difficult to tell, so I'm going to highlight the 3 different groups, okay? Here's the first diet. Those who were fed a diet that is, here's the low in fat and cholesterol and high in fruits and vegetables. Okay, so that's one of the diets. How about if we name it something really shorter like LFHF? V. What does this stand for? Low in fat, high in fruits and vegetables. So that's that one. Do you want to shortcut that? That's at least better than writing out the whole thing, okay? So that's the first diet. Low in fat, high in fruits and vegetables. Okay. And then the second one, so I'm going to highlight this in a different color. Here's the second one. I'm going to do a highlight. Low-fat dairy foods known as the DASH diet. Okay? So, yay. That's easy to say. That is the DASH diet. So, that is the second kind of diet. And then guess what? We wanted to see if it lowered their systolic blood pressure by, or they say, those who were fed those things lowered their systolic blood pressure by an average of 6.7 points when compared to the subjects fed the control diet. So that's the third diet that they're referencing here. These are the three groups, okay? So that's the third diet. All right, so I want you at this point to, you can talk amongst yourselves with your little people around you. Go ahead and finish this problem out, observational study experiment, answer the questions, and if necessary, do the SRAP me capped. You do this here. So we're going to start with our 459 subjects, randomly assign them with a big bag by putting them in a big bag, shaking well, pull out 1/3 of them for each diet. The treatments are the three diets, the low-fat, high fruit and vegetable, the DASH diet, and then the control, which means there was no special diet. Measure each subject's systolic blood pressure change. That's what you were measuring on them. And then compare the average systolic blood pressure change between the what? I didn't finish writing this out. Between the what? The three treatments or the three diets. Okay, very good. And then what's the last part? To see
which treatment.
To see which diet. Let's be specific. To see which diet. What was our goal? Lowers. Very good. Lowers the systolic blood pressure the best. The best. The most. Okay, very good. So please make sure that there, of course, no homework on that. We'll practice a couple more of those tomorrow.